In this example, we're going to balance a redox reaction in base. So you've been asked using this reaction to balance this in base. And the easiest thing to do is actually to start by balancing it in acidic environment first, and then we're going to switch it to being in base. So if you follow the steps from previous examples to balance in acid, then we're going to have this reaction here. To make sure that you can get to this step on your own. Now, this at the moment is balanced in something where we've produced some acid, okay? But we know that this reaction actually takes place in base, so we need to use a bit of chemistry in order to switch it to being in base. And what we're going to do here is we're going to add as many hydroxide ions as we have hydrogen ions in this solution on both sides. So we've got 4 H plus, so we're going to add 4 OH minus to either side of this balanced chemical equation. Now by doing this, we haven't changed anything. We haven't changed the number of atoms, we haven't changed the charge. It's still the same on both sides. Our next step is to use a bit of chemistry to clean this up. So we know that H plus and OH minus actually makes water. So this is going to produce 4 water in my balanced chemical equation. My OH minus on the other side is left untouched. Now at this stage, I have a balanced equation in base. So I required a basic solution in order for this reaction to proceed in this way. At this step, you'll also want to clean up any extra water molecules, because when we're balancing in an acid, we might end up with water molecules on the left-hand side, and those might need to be cleaned up, either by combining or simplifying them. Much like when you've balanced any other reactions, you can ensure by checking the charge in the atoms that it is, in fact, balanced.